All right. Some famous kind of, I mean, we've seen the beautiful photographs of reflections in water, and of course you can have reflection in a mirror. This is what's called a Rorschach ink blot, and so like the ink has been put on the paper, and the paper's been folded in half and reopened, right, for symmetry. And then these were used as kind of like a psychology test at one point to be like, what do you see? It tells you something about yourself, kind of a thing. So what do you guys see in this ink blot? What do you see? An animal?
I see it.
You see an ink blot? Some people see bats. Some people see dogs. Some people like, I see the devil. You know, so like it just kind of depends on. And then of course, then a psychiatrist might be like, oh, you blah 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 because you see this in the ink blot. It's just, it's kind of an older idea, but it's still pretty interesting and entertaining. All right, so but we are going to reflect, of course, triangles and other simple shapes to make life easier. All right, we're going to start off with just a definition. What is reflection? Reflection is flipping a shape and then the specific thing for today is we're flipping a shape over a line. So like a mirror line.
That's what Lauren was doing last night. She needed help with her.
And the line can be anywhere on a coordinate plane or just out there in space between an object. The object can be touching the line. The object, and I think this picture is down here. Oh no, it's on the next page. The object can be laying on top of the line and over the line. That way it's almost like twisting on the line. Here, this is a line. So we have this line of reflection. We say that it's a vertical line, right? But the thing is we have to get a specific equation for the line, okay? So when we talk about details, the only detail is not distance and direction. The detail is the equation for the line of reflection. And that's why I had you pick up your calculators today, because you can always check your equation for your line in your calculator so you don't make mistakes between vertical lines and horizontal lines. Now, this line crosses at the number 5 on the x-axis, okay? So this equation is x equals 5. So we could describe this transformation, reflect triangle ABC over the line x equals 5. All right, so really quick, before we go too much farther, let's just look at what the points are doing. So let's look at point A. Point A is right here, and it's how far away from the line of reflection? How many units?
3 units.
3. And so then it's 3 units on the other side, right?
Yes.
So this side from A to here is the same distance it is from here to there. Okay.
Yes.
Now C is closest to the line, right?
Yes, it is.
And so it goes only 1 unit and 1 unit on the other side. So that's where translation falls apart, because in translation, doesn't every point move the exact same distance? Yes. But what's interesting here is if I were to look at like this, and I connect these two things, and I think about the point in the middle, does everybody see that this piece is equal to that piece? And then guess what angle this is? Right angle. So our line of reflection is the perpendicular bisector between two corresponding points. Okay, so that's deep breath. What was that again? Okay, so a line of reflection, and I think I'm going to write it up here. Line of reflection is the, okay, ready? I'm going to use symbol language. What's that symbol?
Perpendicular.
Perpendicular bisector between, please say excuse me, corresponding points. I'm just going to put A, comma, A prime, right? Like those are corresponding points. So that's like a tell. How do I know if it's been reflected? Well, is the line of reflection a perpendicular bisector? It is. It's a reflection. Okay. So one more thing in this area before we kind of move on. Let's look at those letters around the shape. So remember, we call the letters, did everybody get what, sorry, still writing? Okay, I'll let you write. So remember we talked about the letters naming the shape called the orientation, how we name the shape. So if I were to go around the pre-image, it goes A, B, C, A, B, C, A, B, C. What direction am I going in? Counterclockwise, right? But when I go to the reflection, A, B, C, A, B, C, A, B, C, now what direction am I going? Clockwise. So when we reflect,
You change your direction.
yes. So does the orientation of letters stay the same in a reflection? No. The letters change direction. Doink.
They start it with like BAC.
So to understand, like, so if I name that first triangle ABC, then I'm going to check the other triangle by starting at the letter A, right? So and as we get to comparing more things, and when we get to things that aren't A and A prime, like they might say triangle ABC maps onto DEF. So at that point, when we have different letters, we need to see that A maps onto D and go on from there. And now, of course, let's just really quick look at this. Are the segments still the same length? Yeah, and are the areas the same length and the angles the same length? Everything is the same. So is reflection one of our rigid motions? Yes. And we can talk about same size and shape. It's just been reversed. You guys are probably a lot more used to it than I am. I see reflection, like, just because there's so much like photography and it's easier to look at film of yourself, right? But like when I used to look at myself in a mirror versus looking at a photo of myself, it always felt a little bit awkward because like my part would switch sides and stuff like that, right? Because it's the reflection of yourself, which is flipped, versus the actual image of yourself, which is a picture. So just something to kind of keep in mind, that the idea of the reflection does flip. That kind of keeps you grounded in that. All right, so now we're going to perform a couple. And the thing is we're going to perform 2 on each grid. So this is where colored pencil can be helpful and careful reading will be helpful. They would not do this to you on a test question. I would not do this to you. We're just trying to use less trees and get the job done a little bit easier without having so many examples. All right, so here's our first one. It says graph and label triangle A prime, B prime, C prime, the image of triangle ABC after a reflection over the x-axis. So underline that or box it in or whatever you want to do. This is where you need to slow down, just like counting left and right. We need to just take a moment. Where is the X axis? Is it this way or this way?
Horizontal.
Yeah, okay, great. Now, yes, it's over here, but it's triangle ABC over here.
No.
No. So really, and this is where my color can be helpful, but you have to do it right on the line. I'm going to highlight right on the x-axis right here. Like this is where I'm going to fold my paper. You can do that with a highlighter, a colored pencil. You can just do it with your pen or pencil if you want to just darken it in. And you can see on mine, I did it in orange for this one, right? So you can see like I have it right underneath my shape so I can think about where my shape is going. Okay, so right now my shape is in quadrant number 1, and we're just going to review the quadrant numbers. All I'm doing is planning. Where's the shape going to go? Is it going to go to the left or is it going to go down? Down, down. So it's going to go to quadrant 4. And instead of standing up, C pointing up, what is C going to be doing?
Drowning.
Pounding down, right? So can you everybody picture the flip?
Yes.
Okay, great. So now when you're performing, it's easiest just to do the counting. So if A is 1 above, A prime is going to be 1 below. If B is 1 above, B prime is going to be 1 below. Now, those two are really easy to eyeball, and I'm going to connect them together right now. To do C, there's a couple ways to help you make sure you've done things correctly. First of all, you can look at how far it is from B to C, right? 1, 2, 3, 4 units long. If I want to kind of trace across, I can see, hey, this is 5 units up, right? That means I have to be 5 units down when I reflect it, those ideas. So now it's 5 above the line, it's 5 below the line. There is C prime. I'm going to go ahead and connect my shape. And there's my reflection for part A, or 1. All right, so let's quickly do this and see if we can figure it out. Point A doesn't help as much, but let's do point B and C. So point B's original location is at 4, 1. And point C's original location is at 4, 5. Where is B prime now? What stayed the same? It's still 4 over, but what has happened to the positive one? It became negative 1. And so C is 4, negative 5, which means the rule for the x-axis only is x, y. Okay, and so now this is how we figure out the rule. What happened to the x-coordinate? It stayed exactly the same, so I'm just going to put the letter x. What happened to the y-coordinate? It became negative, or you could say it changed signs, or it negated, so negative y. And that's your rule. X, y, x, negative y, and that's for over the x-axis. Okay? Ready for the next one?
Yes.
Okay. So now it says, graph and label triangle A double prime, B double prime, C double prime, the image of A prime, B prime, C prime, after a reflection over the
Y-axis.
Okay, so let's make sure we know where we're starting. We're not going all the way back to the beginning. We're going to take this guy and flip it, right? And so if we're going over the y-axis, and once again, this is where a highlighter or some sort of marker can help you, I am going to be highlighting or reflecting right here over this line. I'm not worried about the y-axis up above, right? Who cares about that? Only worried about the y-axis right here. So it's going quadrant 4 over into quadrant 3, Roman numeral 3. Do you guys know your quadrant numbers?
Yeah.
Is that something you've learned before? I have some memory tools for that if that's something that's not natural for you.
1 is top right,
Yep.
and then 2, so that's and then 3, and then 4.
Yep. All right. So here we go. Once again, you're just counting over and plotting your points. So A is 1 away from the line. A prime is 1 away from the line. So we're going 1 away from the line right here. That's going to be my A double prime. I know I'm getting a little messy. It's okay. B double prime is 4 away. So sometimes it's kind of nice to be like, okay, if it's 4 away here, well, I'm going to go 1, 2, 3, 4. Or I know that this side is 3 long. 1, 2, 3. The shapes have to remain congruent. And then remember, it's not a slide. See, this line has to go all the way to the far side. It goes from B down to C, or 4 away here, 4 away over there. Here is C double prime. All right, so our shapes are all congruent to each other. Okay, so that means it's a rigid motion. Let's see if we can figure out the rule just using B prime and B double prime. Yes.
Tell me where the tissues are.
There's a box behind you, in front of you, the 4 corners. Yep. Okay. So let's use B prime and see if we can figure out the rule. So B prime was located at 4, -1. And now B double prime is located at -4, -1. There's more than one way to write the correct rule, especially because some kids are just like, I see positive, negative, and now I see negative, negative, and we'll just do that. Does that kind of make sense? But it's easiest to write a rule by always starting x, y. Okay, so this is going to be the rule for the y-axis, which is different than the rule for the x-axis. And I don't ask you to memorize these. I ask you to look to see, are your things following a pattern, right? Every point should follow the same pattern. But let's see what happens. So our x, which is originally 4, did it stay 4? No, it became negative, right? It changed signs. So we're going to have -x. And then our y value was -1. Did it change or did it stay exactly the same? Same, so you're just going to put a y. So a couple last things before we turn the page. Notice how when you flip over the x-axis, it's the y that changes. When you flip over the y-axis, it's the x that changes. One more thing. Let's talk about orientation. Okay, ready? A, B, C, A, B, C, A, B, C. What direction am I going?
Counterclockwise.
Counterclockwise. So then when I go A prime, B prime, C, this one's clockwise. But now, guess what happens here?
Clockwise again.
No, wait.
Counterclockwise.
Counterclockwise.
It goes back to the...
Do you see how it reverses back to itself? Okay.
Yeah.
So there's the thing that we're going to find out is it's like an odd number of reflections. You'll see the orientation switch. So if we did 3 reflections, it would be opposite. If clearly it has switched, reflection has to be involved. That's the poop. All right, you're ready to turn the page. Okay, we only have 2 more to plot and 2 to analyze, and then that's it. You're doing real good. Okay. So now, while we did axes before, and sometimes they might just say reflect over the axis. Those are words. Now we're going to reflect over some equations, okay? So when you have an equation, there is an equal sign. And I need to boot my calculator. So let me quickly do that. And you're going to need to turn your calculators on. Let's see if my calculator will turn on. You can do it. Okay, so I'm going to go back to my booklet. Booklet. Here we go. All right. Says triangle ABC is graphed on the axes below. Graph and label the prime, the image after a reflection over the line y equals 0. Is the y equals 0 the same words as y-axis?
Yeah. No.
No. So y equals 0 is not the y-axis. So this is where kids make simple mistakes and lose points when really you know exactly what you're doing. Okay, so I'm going to go to my calculator. You ready? Calculator. I'm going to go to, so if I go home and I say I want a new document, I want a graph, which is 2. Okay. I'm going to teach you to often delete f of x. Because deleting f of x allows us to type in whatever we want. Did you guys learn that last year?
Yeah.
And okay. So when you delete the f of x, then there's a whole bunch of things there to choose from. Okay. I'm just going to choose the word relation, which allows me to type in anything I want. Okay. So does anybody want me to repeat those steps?
No, Mr. G taught us this last year.
Okay. So now I'm going to type in the equation that they just told me. Y equals is under control, 0. Where does it plot the line y equals 0?
On the x-axis.
Okay. The line y equals 0 is the x-axis. The reason why is because this is the point 1, 0, 2, 0, 3, 0. All the y's are 0. Okay, so back here, the y-axis, or the y equals 0 is the x-axis. Okay, guess what x equals 0 is? The y-axis. They are the same. All right. And the thing is that's the nice thing about relation. You can always remind yourself versus, I'm a big fan of use your tools, you don't have to memorize. Use patterns, you don't have to memorize. Okay? So let's go back to this. If we're reflecting over the x-axis, our line is right here. What do you notice about A and C?
They are standing on y equals 0.
Yeah. So it's kind of like when you put your nose on a mirror, your nose is not going anywhere, is it?
Yeah.
But the things that are farther away from the mirror.
Yeah.
So A and C are just going to stay where they are. They're going to become A prime and C prime. The only point that needs to move is B. So B is 1, 2, 3, 4 above the line. We're going to go 1, 2, 3, 4 below the line. There is B prime. And now we have our reflection over the line, x equals 0, or y equals 0, y equals 0. And then you could talk about how those points are fixed. When points don't move, we say they're fixed. There we go. Points that don't move are fixed. And we had a rule for the x-axis. Once again, I'm not going to worry about that on this page. I only use it if things get wonky. All right. Are we ready for part B? Okay, so part B says, reflect over the line x equals 1. So we're going to go back to the pre-image. Do you see this? ABC, okay? So where in the world is the line x equals 1? I am always going to graph in the calculator, okay? So once again, I pick up my calculator. I can stay right here. I have to hit tab to get back the line where you can put things in, okay? And now I'm going to type x equals, whoops, I'm not in. Sorry, there we go. X equals 1. And so first thing you should notice, is it horizontal or vertical? Vertical. And where is it crossing the x-axis? At 1. Okay? And it's not a function because it fails the vertical line test. And that goes back to last year, right? I put in an input and we all get the same output. The output for everything is, well, I put in 1 and I can get anything. I put in a 1 and I get a 1. I put in a 1, I get a 2. I put in a 1, I get a 3. Right? Not a function. Okay. So back to our picture. We're going to draw our line up here at x equals 1. There's our line of reflection. And now this just requires careful counting. There is no x comma y rule for these. When you're on random lines, x equals a number, y equals a number, there's no rule. So B is 1 away, B double prime, 1 away. I always do the ones that are closest first. C is 1 away, C double prime is 1 away. And now here, I just have to be careful or count the length of the side carefully. A is 3 away from the axis, but it's 4 away from the line of reflection. So now I go 1, 2, 3, 4. Here is, whoops. Here is A double prime. So I have a side length of 3 and a side length of 4. And BA is actually 5 because it's a Pythagorean triple. I love Pythagoras. He's so cool. There we go. All right. How are we feeling?
Yeah,
okay.
Great.
So now I'm okay. So now just a couple last things we're going to analyze. Just if you can see if the line of reflection goes through a shape, then it will overlap, right? Okay, just something to be aware of. There are 2 other popular lines that they like to use. So the first one is the line y equals x. Okay, the line y equals x. This, my friends, is the line y equals x in this picture. Do you see how it goes through 0, 0, 1, 1, 2, 2, 3, 3,
Yeah.
right? That's y is equal to x.
That means the slope is x.
The slope is 1.
1.
1. Rise 1, run 1. Do you see the stairs?
Yeah.
Rise 1, run 1. Rise 1, run 1. Okay, so let's analyze. And first of all, they didn't really do a nice job telling you this, but triangle ABC maps onto triangle DEF. So we're going to kind of talk about lining up your letters. A goes to D, B goes to E, C goes to F. Does that kind of make sense to everybody? And it's okay if like, we'll do this more often. I'm just like very first initial instruction to it. So let's pick, let's use point C and F to see if we can figure out the rule. So C was first. How would you describe the location of point C using coordinate pairs? It's at back 2, up 6, right? -2, up 6. F is its corresponding, okay? Where is F? 6, comma. Oh, did I get a number wrong? I did.
Yeah, it was.
Thank you.
I was gonna say that.
Sorry. And so that happens
it's
to me
okay.
sometimes standing off to the side of the board. I miscount.
Yeah,
So always feel free to stop me, Ms. Rupp. It was 3.
no worries. Miss.
Okay, so now this one is 6, comma, -3, right? So it's actually in the name of the line, what happens? Our X, comma, Y coordinate pair, and this is a rule for this line. So some lines do have rules. This is a nice line. Hey, the X number became the Y number, didn't it? And the Y number became the X number. So literally X, comma, Y becomes Y, comma, X. And so this is the rule for Y equals X. Because Y equals X and X equals Y. Just read it the opposite direction. It's kind of cool that way. Okay? So now you would imagine there's also going to be a rule for this line. So this is the line Y equals -X. You can see it goes downhill using the -1 slope. It goes through the origin. It's kind of like the other 45-degree line, right? When things are square. So let's just analyze 2 points. We can use C and C prime. So C. C is located at -6, comma 1. Now, is it just going to switch the two numbers? Or is it going to be more interesting than that? Just a little bit more interesting. C prime, well, I didn't put my thing in. C prime is located at -1, comma, +6. It does make sense. It's just a little bit wonky. So what happened to the X? It went into the Y position. Whoa. It went into the Y position, but it changed signs. So -X. So X became -X at the end. What happened to the Y? The Y comes first, but it also changed signs. So can you see X equals -Y, like the actual equation for like the equation and the rule go together?
Yeah.
These are ready. It's not usually something you have to but you have to maybe recognize. And it might be in a multiple choice, like A, B, C flipped over, Y equals -X. And you'll have a calculator to check your work and a picture already drawn to check your work. There's a lot of stuff there to help you already. Okay? All right, deep breaths. That's the lesson. That's it. So I have a 1-page homework, front and back, for you to like try to read some stuff and do some stuff and interpret some stuff. Okay?
Yeah.
All right, here it comes. You might want to do the first 3 before you leave because it has where are these equations plotted? So using your calculator to kind of practice which way are X's and which ways are Y's.